Welcome guys. So this is the second video about the theoretical of Ramanujan. So in the previous video that we proved that this guy is 3. If you don't know that, I mean it's fine. Yeah, don't worry. So in this video we will prove the more general results. We will prove this guy. It is this guy. And use this guy to solve this. So usually in many YouTube videos, they only talk about this guy, right? They only talk about this is 3, and the proof way is that if you know the answer is 3, then you can easily write 3 as 1 plus 2 times 4, and then keep going. Then I mean, if you are smart enough, right? Then probably it's easy to get 3. Or if you use a computer to compute up to some radical, up to some square roots, then you can guess the answer is 3, right? I mean, suppose the answer should be some correct one. Okay, so some easier. So in this video, we will talk about more general, like ax n plus a square x times this guy, and we will show this. We will try to use this. We will try to use this to solve the general results. Okay. We will use this result to solve the famous Ramanujan one. So this is a generalization video. Okay, so let's write. So let's write this is f of x. This is very non-trivial. So yeah. So I don't know whether you guys can see the pattern. So this is ax plus n plus a squared plus x, right? And ax plus n. So okay, so focus on the next square roots. What do you get? Right? You get ax. This guy and this. So you see x goes to, so you see okay, so you see this is x plus n and x plus n, right? So you get if you square it, you get this x, right? And this guy will be f of x plus n. I mean, it's very easy. Right? Hope you guys see this. I mean, if you have not see the trick, then you can stop the video and you can stop the video and read the coefficient, right? If you see at x plus n, this is x plus n, Okay, this is x plus n, x plus n. Okay, so the next is that solve f of x. Okay, so it's not obvious that how to solve it, right? But the idea I want to see is that you see this is square, right? This is f. So obviously that f should be linear in x. And the reason is that if x is linear, then the left hand side will be quadratic, and this guy will be x times linear part. So this guy will also be quadratic. Okay, so maybe the proof should be look like if f of x is like cx plus b, then the highest term for left hand side, let's see. So f of x is cxm. And the left hand side, the highest degree for the left hand side will be what? Will be c squared xm, x2m. And the right hand side, this is linear, right? And this is x times, so you get x times cxm plus 1, right? So in order to match these two, c squared must be c, and 2m must be m plus 1. Yeah, sorry. Right. So you will get m equals to 1 and the c equals to 1. Okay, so which tell you that the good answers for this f of x should be x plus something, right? So f of x should be x plus, let's say, b. Okay. And what else we can do, right? We can only plug in, right? So you get x squared plus 2bx plus b squared equals to ax plus n plus a squared plus x plus n plus b. And the times x. Okay, so let's we can cancel this x term, right? X squared term. And then we can also cancel the bx. So the right hand side become nx, and then this become bx. Okay, so in order to match everything, we see the x term, the term context x equals b equals a plus n, and also b squared equals to n plus a squared. Okay, so the final answer will be f of x can only be choose to be x plus a plus n. Okay, so this is the final results. Okay, so let's clean the table and use this generalization results to get the famous answer 3. So what we prove is that this is n plus a plus x. Okay, so it's amazing that one can just write as this. Okay, so now we want to use this to solve it, solve the later one, right? So let's see. Let's see. This is so. Let's see. So you see. So each time you get the next square root, you only get. So there are two terms here, right? But there are only one term in each square root, and this term is always one. So it's not increase. It's not increasing, right? So let's see. So this guy is always one, right? So that means 1 is always ax plus n plus a squared for any n, right? Okay. And the next is so you see so from this, right? I would guess that x must be 2, right? So x must be 2, and that's it, right? X can choose to be 2, right? Right. And let's say n is let's say a is 0. So if a is 0, then x equals to 2, then we get the let's see. So we get the square root of the first term is 0, right? So you get n plus a squared. So your n is the first point. The first starting is xn. So I can let n to be I can let n to be 1, right? So you get 1 plus 2 times the square root of the same thing, right? The same is that and the ax plus n. So this term is always 0, and then you get n plus a squared. So you get n plus a, which is 1. Oh, you see, it's always 1, right? It's always 1. Plus x plus n, so 2 plus 1, which is 3, and keep going. Okay, so if you see, yeah, I mean, this is a little bit confusing, right? This is a bit confusing. But if you see clearly, if you choose a to be 0, n to be 1, x to be 2, then you can see, you start from here and you get you get this one, right? So yeah, you keep going very well. Okay, so the answer will be 2 plus 0 plus 1. So the answer is 3. Okay. Yeah, so this is like a generalization of the original Ramanujan integral into some very bizarre form. I mean, I guess if you haven't seen the answer, it's very difficult to you to start from this, see the generalization from only these famous 3 results to get something which contains 3 variables that you can play around with. Okay, actually, the convergence property of this Nist radical is also very non-trivial, right? So suppose you write any Nist integral, it's not obviously that this guy somehow will converge. Okay, but this is so deep that I will not keep discussing. So yeah, this is the second Nist radical, and maybe we will have third or fourth if there is some other interesting one. Okay, see you guys in next videos. Hope you guys subscribe to my channel.